I'm going to show you a couple examples here about how to solve a system of equations using substitution. First thing that you have to recognize about substitution is that the number of variables you have has to equal the number of equations you have. If you look at these, they are very deceiving. It appears as if we have more variables and not enough equations, but that's not entirely true. I have a y and an x, and I have an x and a y. So when we're looking at your variable count, we are looking at different variables, not the number of that variable that we have. So the first thing that we need to do is we need to know and recognize what the definition of substitution is. Now, substitution says you are going to choose an equation, you are going to rearrange it to solve for one of your variables, you are going to then take that result, substitute it into your other equation, so the one you didn't use. You're then going to solve for the only variable that you can that's left, and then you're going to take that answer and you're going to substitute it back to find your final result. Okay, seems kind of straightforward, can be a little confusing, so let's go ahead and walk through it. The first thing that I need to do to set myself up is I need to take these equations and I need to combine my like terms. And I want to do that because I want to make sure that when I'm working with my systems to solve, I can actually solve them the way that I need to. So I'm going to go ahead and take them and I'm going to combine my terms here. So I'm going to start with the 3y equals x minus a 2y minus 1. So I'm going to combine my y's, so I'm going to move that 2 over. 3 plus 2 gives you that 5y is equal to x minus 1. Now I'm going to do the same thing to my bottom system, or my bottom variables. So here I have 3x equals the 2x minus y minus 1. Combine my terms, so here I have 3 minus 2 gives you that x is equal to negative y minus 1. So I'm going to re-look at what my system actually is. Okay, so the system that I have to work with is going to be 5y equals x minus 1 and x equals negative y minus 1. So here is my system. Okay. Now, substitution says I have to choose one of my equations to solve for a variable. Well, if you look, one of them already did. Okay, so the first step here we're going to look at is called that we are going to choose an equation and we are going to solve for one of the variables. Okay, so that is kind of what we're doing. So here I would choose that x is equal to negative y minus 1 because it's already been solved for. The second step that you are going to follow is you have to substitute into the unused equation. And then you are going to solve for the remaining variable. Okay. So we are going to take this that x equals and we are going to substitute it into the top equation. So here I have 5y is going to equal, notice it was x, so this is going to become negative y minus 1 minus 1. Okay, so the only variable left to solve for is y. So I'm going to add that y to both sides. 5 plus 1 gives you a 6y is equal to negative 2. Divide everything by 6, we get that y is equal to negative 2 over 6, and we have to reduce. So we get that y is equal to negative 1/3. So one of the things that you can see right off the bat is I've already found one solution, which means this is a one solution system. Once I do that, your third step is that you need to substitute the answer or solution, however you want to call it, back into one of the original equations. So we're going to come back up here because you always want to try and work with what you have not manipulated. So we're going to come back up and we're going to just choose one of the equations. Now I like to kind of play leapfrog since I just used my 5y equals x minus 1 equation, which if you remember I solved by combining my top. I'm going to use the bottom equation here. So I'm going to use that 3x is equal to 2x minus y minus 1. And I'm going to substitute in the solution I know. So here I get that 3x is equal to 2x minus a negative 1/3 minus 1. I'm going to go ahead and again combine my x's. So I'm going to move it over. This becomes 5x is equal to, negative and negative is positive, so this is 1/3 minus 1. I want to get rid of my fraction to make things a little bit easier on myself. So I'm going to go ahead and multiply this whole thing by the 3. So we're going to multiply that by 3, which is our denominator. And so here this is going to give me 15x is equal to 1 minus 3. So my 15x is equal to 1 minus 3 is going to give me negative 2. I see my mistake. It's right here. Let me go ahead and get rid of that, which is going to change this down here. Alright, so if any of you caught it, what I did when I combined my x's here is I added them instead of subtract. So what this should have been here was 3 minus 2 is 1, so this should have just been x. So when I multiplied by 3 instead of 15, this should have been a 3. So then I should have had 3x equals negative 2, so x is equal to negative 2/3. Okay. So what this means is that my solutions here are going to be written in interval notation. So when we write our solutions, you have to use interval notation, which says your solution is the form x comma y. So in this case, what this means is that our solution here would be the point negative 2/3 comma negative 1/3. Now, what you would always want to do is you would want to take this solution and double check it. And the way you double check it is by plugging those solutions back into your formulas. So, if in this problem, say I had not caught my mistake, you would catch it when you check your solutions. Because what would happen is that this answer here would not have worked. Okay? So always make sure that you are double checking your work and that you're looking over every step as you go to make sure that you haven't made any simple errors along the way. Now, in light of that, I always have an extra solution or extra equation. So let's go ahead and look at this one so that you can once again see the steps to take. So again, substitution says double check and make sure that the number of variables you have matches the number of equations. 2 variables, 2 equations, good to go. The definition says choose an equation to solve, substitute it into the other, and then solve. Okay? So here, let's go ahead and start. Let's work with x minus 3y equals 8. And let's go ahead and solve for x. So that's what we're going to do here. So here we end up with x is equal to 3y plus 8. Now the second step says that I'm going to substitute, and I'm going to substitute it into the equation I didn't use, which was the 2x minus 6y equals 16. And then this means that here I will be able to solve for y. So we're going to go ahead and do just that. So this is going to be 2 times 3y plus 8 minus a 6y should equal 16. We're going to distribute that 2 through, so we get 6y plus 16 minus 6y is equal to 16. Combine your terms. 6 minus 6 is 0, so I get that 16 equals 16. Now, a lot of students at this point panic. Don't panic. What you should notice here is that this is actually your solution. We call this a true solution, which means this one is infinitely many. And that would be your result. Okay? So here's a note for you to keep in mind. We have 3 solution types. The first one is a one solution, which will be in the form x comma y. Okay? So what that means is that during this substitution process, in this second step, we would have found a variable. Kind of like in this first example here. If we looked at the second step, which to substitute, so we look over here, here's our second step, notice we found y equals an actual value. So this automatically dictates that this was a one solution system. Okay, because we found this y value. Now that being said, the second solution type we have is called infinite, or infinitely many. This occurs when we get a true solution. For example, 16 equals 16. Okay, this right here is a true statement. The third type that we have is we have no solution. So no solution means that we had a false statement. For example, we had 16 cannot equal 3. Okay, so this would be like a classic example of a false statement. That would give you no solution. So when you're working these, this second step that you do here is going to be the most important step, because it is going to dictate which one of these 3 solutions that your system is going to have. Okay? So there you have it. Those are 2 very different examples about solving systems using the substitution method. If you have any questions, please do let me know. If you have any systems that you need help solving, or any other problems that you would like to see completed, let me know that too. I'd be happy to work those out. Otherwise, it's been an absolute blast, and I look forward to seeing you next time.